Welcome. In today's video we're going to be talking about direct variation, and the objectives of today's video is to be able to graph direct variation equations, and then we're going to write the equations of direct variation equations from graph and from an x and y value. So the first thing we're going to want to do is to take a look at the direct variation equation. Y is equal to a times x. Notice that this is almost identical to y equals mx plus b, except we changed the m to the letter a, and instead of having a b value, our b value is always 0. There's no b value here. It's like having plus 0. But we would never write plus 0. It's not necessary. So we just write y is equal to ax. If you have an equation in that form, then you have a direct variation equation. Now we're going to take a look at our first objective, which is to graph direct variation equations. Now remember, they're just like graphing slope-intercept form, except your y-intercept is always 0, and then we're going to use our rise over run to plot two more points before and after that y-intercept. So let's take a look. Again, since the y-intercept is 0, it's y equals 3x, it's like having a plus 0. We graph the y-intercept first, and then we use our rise over run. Notice it's 3, and to make it rise over run, we divide it by 1. So that gives us 3 over 1 being our rise over our run. So our rise being 3 means we're going to go up 3, and our run being 1 means we're going to go to the right 1. So we're going to go up 1, 2, 3 to the right 1, up 1, 2, 3 to the right 1, or we can go down 1, 2, 3 to the left 1. Let me grab those recording bars so you can see further down. And we can also go down 1, 2, 3 to the left 1. After you've drawn your points, you can connect them with a line, and you will have graphed the direct variation equation. Please go ahead and pause the video and graph these two equations on your own, and press play when you're ready to see the answer. For our first equation, again, the y-intercept is 0 since it's a direct variation equation. Your y-intercept is always 0, so we plot 0 on the y-axis, and our rise over our run is going to be -2 over +1. That means we're going to go down 2, 1, 2, to the right 1. Down 2, to the right 1. It also means we can start back at the y-intercept and we can go the opposite direction by going up 2 to the left 1, up 2 to the left 1. Connect your points and you will have graphed the direct variation equation. Looking at the second example, again, your y-intercept is 0 since it is direct variation. There wasn't a y-intercept written, that means it's 0. So we plot 0 on the y-axis, and our rise over run is a +2 over a +3. This means we're going to go up 2 to the right 1, 2, 3, up 2 to the right 1, 2, 3. We go back to our y-intercept. It also means we can go down 2 to the left 1, 2, 3, down 2 and to the left 1, 2, 3. Connect your points and you will have graphed the direct variation equation. Now what we're going to do is we're going to write the equation of the direct variation equation shown on the graph. So to do this, we're going to need to get the equation in y equals ax form. Remember, that's our direct variation form. We have 3 steps we're going to go through. The first step is to make sure that the graph really is direct variation, meaning your y-intercept should be 0. Looking at the graph, you notice the y-intercept is indeed 0. So now all we have to do is to find the a, which you'll remember that's just like the m for the slope-intercept form. We need to find our a value, which is our rise over run. So we're going to start at the y-intercept. Our y-intercept in this case is 0. And we're going to use rise over run to find out what the a value is. So we find another point on the graph where it crosses through the corner of one of those points on the grid. And we're going to find the rise over run to get from the y-intercept to that other point. So our rise is a positive 2 since we went up 2. And our run is a positive 1 since we went to the right 1. So our rise over run is 2 over 1, which is also your a value. 2 over 1 can be reduced to just 2 because 2 divided by 1 is 2. So that means that a is equal to 2. Using this information, we can write the equation y is equal to, now remember a is 2, so we're going to write 2x. And you have written the direct variation equation of the line. Please go ahead and work the following 2 questions on your own, pausing the video, working them out, and pressing play when you're ready to see the answers. You'll notice for the first equation, the y-intercept indeed was 0, so that means it is direct variation, and your rise over run, you had to go down 1, 2, to the right, 1, 2, 3 to find out where it hit another point. Let's verify that. Down 2, to the right, 1, 2, 3. So your rise over run is going to be -2 over positive 3. So your equation then is going to be equal to y equals -2 thirds x. For the second equation, your rise over run was up 1 to the right 1. And we could verify that by going to another point. Notice the rise over run is still up 1 over 1. So rise over run, 1 over 1. That can be simplified as just 1. So your equation is y equal to 1x, or you can reduce that a little further and to say y is equal to x. Now we're on to our last type of problem, which is going to ask us to write the direct variation equation given an x and a y value. The way it's worded is, given that y varies directly with x, use the specified values to write a direct variation equation that relates x and y. Again, very wordy. All it means is we need to find the a value for our direct variation equation. So here's what we're going to do. We have 3 steps, and that's going to get us to our equation from those 2 points. Our first step is to substitute the x and y values into our direct variation equation, y is equal to ax. So our y value is 6. Our a value, we don't know a yet, so we're going to write a. And our x value is -4. Our second step, we're going to solve for a. That means we need to get a by itself. Notice it's a times -4, so we can divide both sides by -4. I'm going to continue my work over here to the right. Notice -4 over -4 is a positive 1. So I'm going to get my a value, and it's going to be equal to 1a, or just a, is going to be equal to 6 over -4. We can reduce that by dividing the 6 and -4 by 2, giving us a reduced fraction of 3 over -2, or just -3/2. Our last step, now that we have found the a value, is to substitute that a value back into the equation y is equal to ax, except x and y are going to stay x and y. So we're going to get y is equal to the a value we just got through finding, -3/2, and our x value is x. Now you might be wondering, why do you keep the y and the x? Why don't we substitute them and keep them -4 and 6? Well, the reason is that the y and x are going to stay variables for your final equation. Here's a couple problems for you to try on your own. Please pause the video, work them out, and press play when you're ready to see the answer. For the first one, you substitute the -10 in for the y. In our equation, y is equal to ax. -10 is equal to a times -5. We divide both sides by -5. -10 over -5 is a +2, so a is equal to 2, which means your final equation is y equals 2x. For the second equation, you substitute 10 in for y, and a stays a since we don't know what it is, times 4. We divide both sides by 4, and we get a is equal to 10 over 4. 10 over 4 reduces to 5/2. So since we know a is equal to 5/2, that gives us our final equation is y equals 5/2 x. And there you go, you've written the equations, or rather the direct variation equations, given an x and a y value.